Good morning and welcome to the International Space Station Flight Control Room. You're looking at a team of flight controllers monitoring systems aboard the station in excellent shape as it orbits the Earth every 92 minutes. The team on console today once again being led by veteran flight director Ed Van Cise. He is joined to his right by Christy Bertels. She's handling the direct communication link between the team here in Mission Control Houston and the crew members aboard the International Space Station that make up the Expedition 38 crew. You see those 6 crew members that make up this crew. The 3 on the left side of the crew emblem are from the far left, Mikhail Turin, a Russian cosmonaut. He served as the Soyuz commander for TMA-11 spacecraft that launched this past about a week ago. Now they arrived at the station on Thursday, November 7th. Seated there next to him is Koichi Wakata, representing the Japan Aerospace Exploration Agency. He'll transition and be the first Japanese astronaut to serve as a commander aboard the station of Expedition 39 next March. The tallest member of the crew on board, Rick Mastracchio from Connecticut, he is on his 4th flight into space. Again, those 3 are enjoying their 8th day in space and aboard the International Space Station now. The other 3 crew members on the right side of the crew's logo are continuing from left to right. Sergei Ryazansky, he's a Russian cosmonaut on his first voyage into space, the 211th individual aboard the station as he crossed the threshold right behind Mike Hopkins, you see on the far right. He was the 210th individual on his first flight into space. And seated is Oleg Kotov, the commander of Expedition 38, a veteran of 3 flights now aboard the International Space Station. 3 different expeditions that he's crossed, part of Expedition 37 and now Expedition 38. These 6 crew members woke up about midnight Central Time, and as usual, shortly after their wake up, the crews conduct their morning duties as usual, and then gather together for a daily planning conference with the flight control teams around the world. That occurred about 1:30 this morning, and then they split off in different directions to conduct a number of different scientific investigations throughout the day aboard the orbiting complex. One of the primary tasks for the day for flight engineer number 3, Michael Hopkins, was to begin an extensive preparation for an experiment known as the Selectable Optics Diagnostic Instrument, or SODI. The experiment samples for that will be coming up on the next Progress vehicle that will be launched from the Baikonur Cosmodrome in Kazakhstan. That 53P Progress is scheduled to launch on the 25th of November, delivering new supplies, experiments, and hardware to the crew aboard the International Space Station. Other crew members taking part in some visual acuity testing, continuing with that activity throughout the day. Crew members, the newest 3, also conducting some familiarization training on board with some of the emergency equipment in the event that there was an emergency on board, very similar to the conduct of fire drills that we go through here on the ground periodically. They'll have an afternoon daily planning conference as well, and before they head off to bed, the crew sleep time as usual about 3:30 in the afternoon. So a busy day for the Expedition 38 crew, being monitored from flight control teams all around the world as they head through what is the 50th day on orbit for 3 of the crew members and the 8th day on orbit for the other 3. While the crew on board worked through the second half of its day, in fact, all 6 crew members gathered for lunch. Their midday, by their time schedule, occurred around 6:30 this morning. So shortly after lunch, for the crew on board here on the ground, the space station mission management team got together. Usually meets twice a week, but Monday being a U.S. Federal holiday, that meeting was deferred to the second meeting of the week today, chaired by ISS Manager for Ops and Integration, or Operations and Integration, Kenny Todd. Obviously is a video teleconference that ties in all of the partners of the International Space Station. It includes an extensive review of what's been going on in the last week or so, and also looks ahead at future activities and discusses any issues on board the station. And there really aren't any issues. There's one minor leak within a system in the laboratory that the mission operations team is tracking, and they'll basically be tracing that leak, but it's been identified as being very, very slow, and so they'll start trying to isolate that behind one of the racks in the Destiny laboratory, probably sometime next week. They also have been discussed the collection of some microbial samples within the Russian segment water system, and have determined that the water system is fine for the crew members to consume or use with preparation for their meals on board the station. And there's also a discussion about the recovery of an extravehicular mobility unit, EMU, with a serial number 3011. If you recall, Luca Parmitano had an issue with that suit with a water leak, and there's continuing to be troubleshooting associated with that. But there is a methodical approach to bringing that suit back online and returning it to service. So there was some discussion about that, but there's a plan for next week to conduct some pressure checks associated with that suit, which is one step in the process of returning it to service. The view you're looking at is from the Harmony module of the International Space Station, looking toward the Destiny laboratory. As you see, Oleg Kotov, the commander of Expedition 34, translating through the module all the way through Unity and up through and into the Russian segment of the International Space Station. From this far end of Harmony all the way to the far end of the Russian segment, the station extends 240 feet in length. And Mike Hopkins, you see there with a CTB, that's an acronym that stands for Crew Transport Bag. It's really an onboard storage bag for equipment and experiment hardware. Harmony joined the station in its assembly process back in October of 2007 as one of the 3 major hubs or connecting nodes that allows for the addition of other modules to the station with various docking ports or attach points. Once Harmony was added to the International Space Station through the assembly process, it provided those additional docking ports necessary for the addition of 2 more laboratories, the European Space Agency's Columbus laboratory, which arrived at the station a few months later in February of 2008. And opposite Columbus on another docking port is the Kibo laboratory, the Japanese laboratory, Kibo standing, the Japanese word that stands for hope, joined a few months after that in June of 2008.
Moscow Station on space to ground 1. На связи.
Go ahead.
Я приступил к работе с прогрессом.
I started the operation with the progress. Click check. Okay, copy that.
At 10:15, about a little more than 4 minutes from now, we're going to head for a weekly check into the Payload Operations Integration Center at NASA's Marshall Space Flight Center. That facility controls pretty much all of the payload activity that goes on aboard the station. You'll hear quite a bit of scientific investigation talk between the crew on board and different investigators associated with experiments, the number of experiments that are going on board. So we'll be heading there shortly to get an update from Marshall on activities associated with experiments on board and other items of interest in the science world of space station experimentation. In and around all of the other activities that crew members have in their timelines today, the 3 newest crew members, usually for the first week or two of their after arrival at the station, are allotted time to what's known as adaptation and orientation. That includes some free time for them to basically look around the station and understand how things are laid out because they're going to be there for 6 months. They'll overlap, obviously, with 3 of the crew members for a good bit of that time, but life aboard the station is something that becomes normal for crew members rather quickly, and so they're allotted time each day for that adaptation and orientation aboard the station of the entire complex. Two of the crew members also today will take time out a little bit later this morning to take part in some interviews. Mike Hopkins will talk with ESPN's Sports Center, and Rick Mastracchio will talk with a television station in his home state of Connecticut. Both of those, as you see, will be coming up a little bit later this morning at 11:47 Central, 12:47 this afternoon Eastern Time. In addition to the Mission Control Center here in Houston, obviously the space station is overseen by a number of flight control centers around the world. talking just a few minutes ago about one of those, the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, is one of those and the primary interface for all of the experiment activities on board. Let's head to Marshall now and get an update. Lori Meggs is there. And Lori, I understand we're talking about space station technology that's turned into a fairly marvelous spinoff for us here on Earth.
That's right. NeuroArm is a clinical research project where a robotic arm works hand in hand with brain surgeons. It works like the Canadarm robotic arm on the space station, although on a very much smaller scale. Now, Dr. Garnett Sutherland, he is a professor of neurosurgery at the University of Calgary, and he shares how this technology has become quite a game changer in the operating room.
Project NeuroArm is the idea of translating all the great research and development of space robotics into the operating room here on our planet.
So we're talking about interoperable surgeries, right? Interoperable brain surgeries that are now...
We're talking about brain surgery, and we might use a statement that the outcome from brain surgery, while being great, can get better. And for us to make it better, that probably does require collaborative efforts between science, engineering, and medicine. And one philosophy we had is, would it not be wonderful if one could merge diagnosis with therapy? That would require advanced intraoperative imaging, and to put machine technology into the imaging technologies so that you can conduct operations while you're taking the pictures.
Wow.
So that would allow surgeons to do things they currently can't do, and that would allow surgeons to always know the effect of what they're doing as they're doing it.
So how has this all come together? How did the neurosurgery world meet up with the robotics world?
So many years ago, we began a project on building an intraoperative MRI device. And so we built one, we put it on the ceiling of an operating room, and it can come in and out as the surgeon wants. But that interrupts surgery during imaging. So I remember around 2002, I phoned a company called McDonald Detweiler Associates. They're the company that built SpaceArm and the Special Purpose Dexterous Manipulator, and said to them, you know, you people build complex robots for complex places, and I would like to join a project where we build a robot for that magnet that we can put inside the magnet, and it can conduct neurosurgery inside the bore of a MR machine. So that project began around 2002, and the robot was delivered in about 2008, and we redid the intraoperative MRI project around 2010, and now we're using the robot for clinical cases.
Tell me how the MRI is involved with that.
If you have a neurosurgical problem or neurological problem, you will commonly go see your doctor, and your doctor will send you for an MRI. An MRI allows your physicians to see inside your body, specifically your head. So we can see your brain, and we can see the problem that's affecting your brain. Furthermore, the MRI gives even more information, like where are the important areas in your brain that need to be avoided, and it even can display the connections between the right and the left, and between within the hemispheres of the brain. So we have this rich data set of everything of your problem and its effect on your brain. Then you go see your neurosurgeon, who tends to operate on you, knowledgeable of the images, but doesn't actually operate in the image. So the theme of this project is the person would be getting images, but then the robotic arms would enter the image and remove it while you're taking pictures of it. And that's the fundamental goal of the project.
What does the robot look like?
He looks like a surgeon without a head. So the robot has two arms connected to a base, and the robot's arms are much like a human's arms, and they have joints, much like a human's hands have joints, and the surgeon controls that larger robot using hand controllers, which are really miniature robots. So however the surgeon moves their hand, the robot moves. So the robot is slave to the motions of a human surgeon. So then our patients come to the hospital, they see us in our clinics, and we schedule them for surgery, and we tell them that we're going to use the robot for part of your operation, and we believe the robot is a benefit for your operation. And invariably people want the robot used. In fact, you can sometimes see a little, not a tear, but a disappointment should you say, no, we're not using the robot for your case, type thing. And then we begin that process of showing how the robot benefits or doesn't benefit a surgical procedure.
Let's talk about success stories. Tell us some.
Well, our very first patient was a young woman with a complex brain tumor. And she just had her child. So we took her tumor out of a small opening using the precision and accuracy of the machine, coupling it to the executive capacity of the surgeon at a workstation and or the assistant surgeon. And we've had many more than her since. And we tend to use the robot at least once a week.
What would have been her prognosis had you not been able to use that?
So in these particular cases, her prognosis would have been pretty good using conventional surgical technique, but we're trying to show that with machines and surgeons, we will always deliver an excellent outcome. So that might say I would like the bar to be raised. And the other thing about machines, like a robot in an operating room, is all the data is digital. So everything is recorded. So people can play back and learn from that procedure. And in theory, they can play forward, which is one of the goals of the project, to feed your MR machine, your MR imaging data into the robot's workstation and practice your surgery before you actually do it.
So is it also being used to train surgeons?
Yeah, so this is a platform which we would expect to be an ideal training platform for surgery. Much like a pilot will go somewhere into a virtual pilot,
Like the simulator.
virtual airplane simulator. Robotic surgery offers the potential of simulation for the young trainees of surgery.
And those are just the Earth applications. The commercial production of these units is now much smaller and lighter and could be carried back to space to use on long-term missions. Now let's take a live look inside the Payload Operations Integration Center where they're busy at work today. Pat Patterson is the Payload Operations Director, assisted by Donna Simpson. The team here has been working this morning with the crew to install the SOTI experiment into the Microgravity Science glove box. That's for a 16-day checkout. SOTI studies colloidal particles in microgravity. Our understanding of these particles could improve our ability to produce and store these materials found in things like paints, food products, and even ceramics. And that will do it for us from the Payload Operations Integration Center here in Huntsville. Now back to you at Mission Control in Houston.
Thank you very much, Lori. That was extremely interesting, and one of the items Lori mentioned there at the end relative to SOTI, as she mentioned, there's an extensive amount of work ahead of the crew members getting ready for the actual conduct of that experiment, and they'll be preparing the hardware on board the station to accept the samples coming to the station on the next Russian Progress supply vehicle, which is scheduled to launch November 25th and arrive just a few days later, delivering those samples. Again, with the extensive amount of hardware set up associated with that experiment, the crew starts now so that they're ready for those samples and the sample processing when the time comes. While the flight control teams on the ground continue to monitor systems aboard this station, let's take an opportunity now to meet the 6 crew members that make up Expedition 38. And that was the Expedition 38 crew, obviously a crew of 6 right now. Over this past weekend, for one of the rare occasions, there were 9 crew members on board following the arrival of the 3 newest crew members this past Thursday, 1 week ago, this afternoon, or this early morning. The 9 crew members are reduced to 6 on Sunday, when Karen Nyberg and Fyodor Yurchikhin and Luca Parmitano returned home and left behind the 6 crew members of Expedition 38. The 3 crew members that have been there the longest, Kotov, Ryazansky, and Hopkins, will return home next March, scheduled for March 12th of 2014. At that point, the other 3 crew members, Mikhail Turin, Rick Mastracchio, and Koichi Wakata, will transition to Expedition 39. And Wakata becomes the first Japanese astronaut commander of the International Space Station. The seamless handover and transition from one expedition to another has been continuous now for 12 years. When the first expedition crew, Expedition 1, launched to the station back in on October 31st of 2000, arriving at the station on November 2nd, and on that same day, early morning hours, opening the hatches, which officially began the permanent human presence aboard the International Space Station, and that continues to this day. Of course, the assembly process of the ISS began before that. Obviously, several of the modules that make up the overall complex of the ISS had to be in place, providing not only some early research capability, but the primary reason was to have a life support system for the crew members before they arrived. So before Commander Bill Shepard and cosmonauts Yuri Gudzenko and Sergei Krikalev arrived, the station was at a very small size comparatively to what it is today. The first element launch of Zarya, the Russian module that served as the what's known as the functional cargo block, was the first element launched on November 20th of 1998, the 15th anniversary of that assembly start of the ISS, obviously coming up next week. And of course that was followed shortly by the Unity module, one of the first of 3 connecting hubs of the International Space Station, providing docking ports for future elements. Unity not only brought, Unity was delivered aboard Space Shuttle Endeavour, and it not only brought that module, but it also brought 2 pressurized mating adapters, one to serve as a permanent interface between Unity and Zarya, and the other to serve as a docking port for future arriving vehicles, which for the most part during the assembly phase of the station were Space Shuttle orbiters. And once that occurred in July of 2000, Zvezda arrived, which was the command and control, the early command and control function of the station. Zvezda to this day serves that function for the Russian segment of the complex. And of course, once that occurred, the station was of a capable size to accept the first crew of Expedition 1. earlier today, after the crew members woke up and had their early morning teleconference with the ground, they and headed off in different directions. So one of those directions was to the Kibo Laboratory, the Japanese laboratory of the International Space Station. Koichi Wakata, representing JAXA, the Japan Aerospace Exploration Agency, headed into that module to work with the setup for a new camera system that will begin testing next week. There's an elaborate system associated with what's known as the 4K camera for an eventual test downlink in December.
As previous that you report to us, is it correct?
Yes, that's correct. And when I push the enter button, nothing responds here.
Understand, after the enter button, nothing happened on the encoder.
That's correct.
And just to clarify that, just now you mentioned that the LCD display is black. That means nothing, no letter, no text is shown on the display. Is it correct?
Actually, that way I'm showing you have the starboard camera. It is, you know, the LCD is working, but it's just, okay, okay.
Some of their troubleshooting efforts included the encoder associated with that new camera, the 4K camera. If that is not recovered, the Japanese encoder, then there are other options, including use of the U.S. encoder, which can interface with that camera as well. So you're seeing footage from earlier in Koichi Wakata's day when he was working with that new system that hopefully will be activated and operational and used beginning in December. In the background, while you see Koichi Wakata in the foreground showing his flight control team, the encoder associated with that 4K camera system, you see the small airlock that is a very unique part of the Japanese experiment module Kibo. Through that airlock, there are various types of experiments and samples that can be placed in that airlock. It can be depressurized to the vacuum of space, and then without depressurizing the station complex itself, and then those experiments can then be translated or relocated to the outside of the station on the external facility or the exposed facility of the module, affectionately known as the back porch, on which is also located a robotic arm, a small Japanese robotic arm. Next week, in fact, Koichi Wakata will be deploying 4 small satellites as part of the Small Satellite Orbital Deployment Program, sponsored by the Japanese Space Agency. Those small CubeSats were briefed. That whole process was briefed to the mission management team today as a readiness for the deployment, which is scheduled to occur on.
So we would like to close out for this task for today.
Scheduled for deployment on the 19th and 20th of next week. That'd be Tuesday and Wednesday.
Okay, so the step is 3.3.
Okay, 3.3.
And also for the closeout, when you, if please look at the storage notes that they have three items that would like you to report which serial number items you retrieved to use for. So it's okay. If you have time, please let us know by call or on the crew note.
And this is a view of Koichi Wakata in the European Space Agency Columbus Laboratory. A number of science investigations are carried out within that laboratory as well. Some of the human research experimentation that goes on routinely aboard the station includes some ocular health investigations whereby the crew members basically test their visual acuity. And there's different methods for doing that on board the station to discern whether their visual acuity changes over the periods of their long duration stays aboard the complex. One of those is a use of a system known as tonometry, which essentially is a measure of the intraocular pressure of the eye. If you've ever had an eye exam, you know what that test is like, and there's a method for being able to do that as well on orbit periodically, and obviously capture that data for investigation by the scientists and medical folks here on the ground. And that rotates around the three crew members for performing that periodic ocular health experiments aboard the station. In its current size and space, the station has a mass and space of a little more than 900,000 pounds, with internal habitable volume of more than 13,600 cubic feet. So at any given time, these crew members can be in totally separate places performing experiments or adaptation, as you saw just a moment ago with Rick Mastracchio. He's budgeted basically to spend some free time learning all of the nuances of the International Space Station. Crew members also today and periodically as well perform some onboard emergency training and review of where all of the emergency equipment is located. Today the crew members focused on the familiarization with the masks that they would wear in the event of any kind of depressurization, or if for some reason the air quality deteriorated, that they could put on these masks. So they familiarize themselves with the location of the masks and also, of course, how to operate them effectively. Crew members, again, also are budgeted each day for exercise aboard the complex twice a day, usually in the first half of the day and the second half of the day for cardiovascular and musculoskeletal training to keep their bodies as conditioned as possible before they return home. They'll wrap up their day with another daily planning conference at 12:35 this afternoon Central Time with all the flight control teams on the ground, and then head to bed about 3:30. They'll wake up again Friday about the same time, midnight Central Time, 1 o'clock in the morning Eastern, to begin their next day on board. Just a reminder that upcoming at 11:47 Central, 12:47 this afternoon Eastern Time, Mike Hopkins will talk with ESPN's Sports Center, and Rick Mastracchio will visit with a television station from Waterbury, Connecticut, his home state, on his early stay aboard the station after being aboard now for a little more than a week. So stay tuned for that on NASA TV, upcoming about 45 minutes from now, and also next up, the video file program with highlighting activities that are ongoing all over the space agency, that coming up here at the top of the hour, 11 Central, noon Eastern Time. And we'll see you back here again for another hour of coverage of ISS activities at 10 a.m. Central, 11 Eastern tomorrow, Friday. This is Mission Control Houston.